Several weeks ago, I had this uneasy feeling. After countless conversations, it was clear to me that there's definitely still a healthy skepticism on the inevitability of carbon removal. And that's fine, but it begged the question, if we choose not to pursue carbon removals and come 2032, we've failed at decarbonization as well, what lever are we then left to pull? It was then that I realized I didn't really know the answer to that question either. Of course, there was one completely mysterious field of study that I'd heard of, but like most people, I'd mentally filed under totally crazy and not even worthy of discussion. But in a crisp moment of clarity, I realized that climate change is just so big and our track record so poor that I don't think any idea should be off the table. No conversation too uncomfortable or topic too taboo. Solar radiation modification. Yeah, I'm doing it. Let's go. Solar radiation modification refers to a handful of technologies that cool the Earth by reflecting sunlight back into space. I put this to David Keith, the leading expert on solar radiation management, to learn more. Professor Keith, it's a pleasure to talk with you. What is solar radiation management?
Solar radiation modification or solar radiation management or solar geoengineering or solar climate intervention, these are all terms for, in my view, the same set of things, which are ways that humans might deliberately alter the radiative balance of the Earth, the balance between the amount of sunlight that comes in, the amount of infrared that goes out, which affects the Earth's climate. We might deliberately alter that to reduce some of the risks of accumulated carbon dioxide.
This sounds profoundly futuristic, right? Not quite. It was actually proposed within a report by President Lyndon Johnson's Science Advisory Committee as a potential solution to global warming. Are you ready for the utterly astounding part? When it comes to combating global warming, some SRM approaches would likely be almost immediately available, insanely cheap, and astoundingly effective. That's right, you heard it here first, folks. We have solved climate change. Thanks for watching, and good night. Well, not exactly. You see, when it comes to SRM, there are two massive issues. One, deploying SRM would treat the main symptom of climate change, warming, but not the underlying problem of carbon. This is extremely important. SRM fails to address the wider impacts of increased carbon dioxide, like ocean acidification, whereas reducing emissions, as always, and carbon removal, on the other hand, do. Issue number two, well, though it would be highly effective at reducing warming, it certainly doesn't come without risk. One concern you hear most frequently on SRM is that it could decrease rainfall globally.
I think you're right that is a concern. So objectively, when you try and ask people what they've heard about it in polling, that is a common concern. It's not obvious that it ought to be a concern. What the climate impasse community would say people should actually worry about are extreme precipitation. These are the big rainfall events that cause flooding, or changes in water availability, which is really precipitation, that's the water coming in, minus evaporation, the water going out. And so really what we should focus on is changes in water availability or extreme precipitation. And so far, the evidence is solar geoengineering could reduce changes in both those quantities.
Other potentially very negative impacts include changes in ocean circulation and the possible risk of termination shock, which is the rapid rise in temperatures if we were just to suddenly stop. Let me be clear on this. I am not, nor has any serious researcher ever proposed SRM as a substitute for emissions reductions or to use it soon. I recently came across a fantastic tweet storm by climate scientist, IPCC author, and lead climate researcher at Stripe, Zeke Hausfather, where he shared a possible scenario in which we might actually require SRM as a last resort. Hey Zeke, great to chat with you. Per your Twitter thread on climate sensitivity, what might a possible scenario for solar radiation modification actually look like?
So it's a great question. One of the challenges with climate science writ large is that there's a lot of irreducible uncertainties around the climate system response to our emissions. So we can have a lot of control over the emission side of the equation, but that's only one of three big uncertainties that determines future climate outcomes. The other two are how sensitive the climate is to our emissions, and then a slightly less appreciated one, which is changes to the carbon cycle feedbacks as the Earth warms. And so because of all these combined uncertainties, even if we think we're going to end up at, say, 2 degrees warming, there's a risk we end up at 3 degrees warming if we roll, ones on all the proverbial climate dice. And so the reason why I think it's worth at least doing more research on the SRM side of things is because of those large uncertainties. Having something in our back pocket as sort of break the glass in case of emergency way to pause everything for a while, to put the warming on hold, is useful. But I think it's important to recognize we're still going to have to actually remove carbon from the atmosphere to get global temperatures back down.
Let's take a deep dive into the following methods. 1. Stratospheric aerosol injection. 2. Marine cloud brightening. 3. Cirrus cloud thinning, which isn't technically SRM. And 4. Ocean mirrors. There are others, like space mirrors, but I definitely thought I'd keep this video very terrestrial. Stratospheric aerosol injection. This is Mount Pinatubo. In 1991, Mount Pinatubo erupted, spewing 30 megatons of aerosol-forming sulfur dioxide 20 k's into the stratosphere. And the unique thing about aerosols, well, they scatter light. In fact, Mount Pinatubo ultimately reflected 2% of sunlight, decreasing the average global temperature by 0.5 degree Celsius for a total of around 18 months. Stratospheric aerosol injection is therefore the replication of this process by using a fleet of planes at high altitudes to spray, in one proposal, 250,000 tons of sulfur into Earth's stratosphere each year, with the possible goal of halving global warming, though it could obviously be deployed more incrementally. How confident are we that stratospheric aerosol injection would actually combat warming?
So there's just an enormous amount we don't understand on the one hand, but a lot of those things are details. So there's a bunch of details about exactly how much, say, sulfate aerosols would heat the lower stratosphere. There's questions about what the aerosols that we put in the stratosphere or could put in the stratosphere, they're going to come down to the troposphere, what they do as tropospheric chemistry, what their impacts are on air pollution. So there's this like endless laundry list. On the other hand, there's a way in which we do know quite a lot because stratospheric aerosols have been studied for more than half a century of science. And I think the confidence that these things could reduce global average temperatures are, in fact, extremely high.
Another more localized method of reflecting sunlight is known as marine cloud brightening. To best understand cloud brightening, let's talk about rain. Did you know that water vapor at 100% humidity doesn't automatically condense into droplets? I didn't. In order to do so, the vapor requires a tiny piece of dust to form around. These pieces of dust have a name. They're called cloud condensation nuclei, or CCNs. Right now, the air around you and around me probably has about 1,000 CCNs per cubic centimeter. However, over the ocean, the air is pure, right? So it probably only has about 50. Marine cloud brightening is therefore the process of increasing these numbers by spraying filtered seawater from vessels into the air, where the tiny pieces of salt act as those little CCN particles. That increases the count of smaller droplets, which ultimately brightens the cloud, reflecting more sunlight. One such proposal to do this at scale involves building a dedicated fleet of 300 ships with these cool little Flettner rotor thingies. They're ideal vessels for traversing the ocean, filtering and spraying salt water into the sky as they go. It seems to me that there are some benefits of marine cloud brightening over stratospheric aerosol injection.
Well, first of all, I think there's less confidence that it could work at all. But assuming that there are substantial areas of these marine stratus clouds that you could make whiter, I think there's an advantage for a local country or region that could potentially kind of modify its local climate in a way that might be beneficial to it. But I think that benefit comes with a disadvantage, which is the world is all interconnected. There's a kind of push me, pull you. So if there's a local modification in one place, it makes a distant modification. Climate scientists have a fancy word called teleconnections for these things. I think what you can say with confidence is that if you want to achieve the same reduction in global average temperature, let's say, if you do it with cloud brightening, it will be more patchy than if you did it with stratospheric aerosols.
Cirrus cloud thinning. Another cloud-related proposal for cooling the Earth is known as cirrus cloud thinning. Though not technically SRM, cirrus cloud thinning is concerned with reducing the size of clouds. But Marcus, I thought you just said that larger clouds were better. That's right, and great to see that you've been paying attention. But there is one type of cloud, cirrus clouds, that unlike the rest cause a net heating effect on the Earth. It's not all that important for this video to understand why, but essentially what you should know is that seeding them with ice nucleating substances may, through a pretty tenuous chain of effects that I don't fully understand myself, reduce their size and therefore their warming capacity. In 2021 though, the IPCC however deemed that this method was too uncertain to warrant much attention. The final, almost legacy method at this point is ocean mirrors. Just like brightening clouds, it's possible to actually brighten the ocean surface itself through creating tiny bubbles from the wakes of ships. Yeah, I'm literally talking this and this. Pre-existing ship designs, however, are obviously not optimized for maximum bubble creation. Their lifetimes are only in the order of minutes. Ocean mirrors therefore refers to the idea of retrofitting pre-existing cargo ships with bubble generators, materially increasing the reflectivity of our oceans. The challenge here is that these foam generators would be energy intensive, and the longer the desired lifetime of foam, the higher energy put required. Likely have far-reaching impacts that are negative on marine ecosystems. Whew. Now that we understand the four methods, we can get into the debate. And boy, is there a lot of debate. These solutions are highly contentious, anathema to most climate folk. And for good reason, right? The list of arguments against deploying SRM is long. The most compelling arguments are that it doesn't solve the underlying problem, it could incur risk compensation, the possibility that it would detract from the urgency of climate action. It may create winners and losers, which unlike global warming are directly motivated to influence those with the hand on the lever. And perhaps most disconcerting is the ever-present possibility of unknown unknowns. There's also a genuine disagreement about the science. Now, on the other hand, some of the less obvious reasons for pursuing SRM are that each passing year there will be more increasing calls for SRM research, whether we like it or not. It's unfair for those least affected by climate change, first world countries, to withhold choices from those most affected by climate change, which is developing nations. And another reason is that we need to research it in order to effectively argue against any foreign power threatening to deploy it unilaterally. Okay, great. So how on earth are we to approach SRM research and governance then, if it is so damn confusing? Well, that is precisely one of the central questions posed by the newly formed Climate Overshoot Commission, whose executive secretary I spoke with earlier, the awesome Jesse Reynolds. Jesse, a lot of noise about the Climate Overshoot Commission. Who makes up the commission and what's its purpose?
Climate risks are growing, and there's evidence that sunlight reflection methods could reduce those risks, although they would do so imperfectly, and they would bring with them significant governance challenges. And it's in the face of these rising climate risks that it appears time to have wider conversations about ways in which SRM may contribute to a bigger toolbox, shall we say, of approaches to reducing the ultimate impacts on people and the planet. The Climate Overshoot Commission is a collection of independent, eminent leaders, and their list includes 4 former presidents and prime ministers, 5 national ministers, a few leaders of intergovernmental organizations, and a few leaders from major environmental organizations. And my sense is the fact that these 15 commissioners have accepted these invitations indicates that there's a growing willingness to at least talk about this. But to be clear, the commission has no ex ante position on what their conclusions regarding SRM may be. Everybody in their right mind agrees that emissions cuts should happen. There's disagreement about who and how and so forth, and that's been negotiated for years. Let's set those off to the side for just a bit so that we can focus on these other approaches: enhanced and accelerated adaptation, carbon dioxide removal to clean up the greenhouse gases that we've been putting into the atmosphere for 200 years, and possibly reflecting a small portion of incoming sunlight to temporarily cool the planet.
Wow, like I said, what a massive topic. No matter what your opinion is here, it's clear that we need more discussion about this in the open. In fact, perhaps the only concrete takeaway is this. We need to ensure that more fields in the humanities or philosophy are involved in SRM discussion. Thankfully, I think that's already going in the right direction. We also need to demand that every segment of society can vote on the outcome. But where does that leave us with carbon removal? Well, I think precisely where we started, with a choice. How hard are we willing to fight before the choice is already made? So that's it for this week's video on SRM. Don't you worry, I'll be going back to carbon removal from here on out. I just really think it's an important anchoring exercise at minimum with emissions reductions and CBR. I'm gonna leave you with some sick jazz. Cheers.